You will not feel it's very difficult to compare it to
Well, thank you for coming today. I'd like to talk today about the success of the smelliest and the way that I've been inspired by evolution in my research on pheromones. I want to focus on just one aspect of pheromones, which relates to sexual attraction, and this is one of the things that Darwin was very much aware of. Now, that's Darwin's statue from downstairs in the University Museum here. And he introduced the idea of natural selection and the possible mechanism, that there are variations between individuals, that some individuals will survive better in the struggle for life, and that their offspring will inherit these variations, and that will lead to evolution. But he also recognized that some males do better than others, and there's a struggle between males for females, and that was sexual selection that fits into natural selection. So, in his book, The Descent of Man and Selection in Relation to Sex, in 1871, he took up these themes. And what we have on the right is a pair of red deer stags fighting for access to females in a harem. And on the left, we have the classic example you'll be familiar with of female choice, which in the peacock has led to the extraordinary and extravagant tails in the males. And this is all due to female choice. But in the book, he was very well aware that chemical signals and smells might well be important. So in The Descent of Man and Selection in Relation to Sex, he includes smells in sexual selection in just the same kind of way as the peacock's tail or the fighting red deer. And he's got a lovely example where he writes, during the season of love, a musky odour is emitted by the glands of the crocodile and pervades their haunts, so conjuring up wonderful smelly images. But he goes on to describe smelly male elephants in the breeding season, male pythons, male moths, and even male birds. He's got a wonderful account of the Australian musk duck that smells even before you see it. He also goes on to describe goats. The rank effluvium of the male goat is well known. And indeed the Latin name of the goat has given its name to a couple of smelly fatty acids up there, which we also find in humans, which we'll hear about later. And if only our noses were as good as our eyes, perhaps we'd appreciate goats more in the breeding season. So he actually develops this idea and says, how do we get these elaborate odour glands in male mammals? And he says it's intelligible through sexual selection if the most odoriferous, that is the smelliest males, are the most successful in winning the females, and in leaving offspring to inherit their gradually perfected glands and odours. So he sees them as a thing of beauty. Now I would say, although he didn't, that this is the success of the smelliest. And that's my aim today, to persuade you that this could be happening. So what are the characteristics of sexually selected signals in animals? Well, he said elaboration or expression of the signals in only one sex, like the peacock's tail. The female doesn't have that. Development only in the adults, often only in the breeding season. So like the crocodile smelling of musk, only in the breeding season. And then finally, the question is it used primarily or exclusively in mating? And for all of these, it does seem to be that odour signals and the glands that produce them show all of these characteristics. So there really is a challenge, though, of these invisible odour signals. Nico Tinbergen, who is a professor of zoology here, came over from the Netherlands, was one of the people among many who studied courtship in butterflies that involve smell. The female butterfly, in the final stages of courtship, puts her antennae between the wings of the male and touches them against specialised scent scales on the wings. He worked actually in this building because zoology was based here until 1971, and of course he shared the Nobel Prize for his work in creating the field of ethology in 1973. But there really was a problem for Tinbergen and everybody else who had worked on smell through the centuries. Surely there was something to do with smells, they were chemicals, but there was no proof. The quantities were vanishingly small. And it wasn't until 1959 that we have the first pheromone identification, the first chemical identification of the female sex pheromone of the silk moth, Bombyx mori. And this gives the name, of course, to bombicol. It was by Adolf Butenandt, a Nobel Prize-winning chemist, and a very large team working over something like 30 years. Now, he created the gold standard for how you identify pheromones. And what you always have to start with is a bioassay. And in this case, it's the fluttering of the wings by the males when they get excited by the female sex pheromone. Having got your bioassay, in his case, he needed 500,000 females to get enough material, just 12 milligrams, to do the chemical identification. Today, you could do some of those tasks with a single female. That leads then to the identification of the chemical, the synthesis of the chemical, and then crucially, that final step of bioassay to confirm that the synthetic molecule that you've created, or molecules, actually does generate the behaviour in the animals concerned. So indeed, the synthetic pheromone does elicit the same behaviour in the male as the natural one. So also in 1959, a new word had to be created for this new class of biologically active substances, and Peter Carlson and Martin Lucia proposed pheromone, a chemical signal transmitted between individuals of the same species, and they derived this from two Greek words, transferred excitement. So back to sexual selection. Well, we're familiar with contests like these red deer stags, but it also happens underwater with pheromones. Lobsters and crayfish fight. Now, part of it's physical boxing, but there are also chemical signals in the urine that they're puffing at each other, which have been visualized in this photograph by giving the crayfish a fluorescent dye so we can see what he's squirting. And females choose the winners. It can also be simply a matter of getting there first, a scramble to reach the female first. And male moths are one of these examples. The female sex pheromone is released in tiny quantities, just picograms per hour, and the males compete to find her. And what we find is that there's very heavy selection on males for high sensitivity to pheromones and fast flight. And you get these amazing antennae that are like molecular sieves that he flies through the air, catching every molecule of female pheromone that he can. But there is also female choice, and this is enormously important. It's true in the case of the peacock, but it's also true in many other animals involving pheromones. And in this is a male moth, and these balloons sticking out of his abdomen are inflatable structures on which he'll display the pheromone down in the bottom right to the female. And unless he has enough of the pheromone, the females won't be interested. So, what about humans? Well, this was the title of a wonderful book by David Stoddart in 1990. He had this idea, which I agree with, that humans are probably the smelliest of the primates. And he proposed that the thing that's unique about humans is the armpit. And perhaps this was a scent box for giving out pheromones. So, since we're mammals, should we have pheromones? Well, the answer is yes, and Darwin would have been pleased with this, because mammals basically smell, and we are mammals. So, what are the characteristics of sexually selected signals? Well, elaboration or expression of the signals in one sex doesn't quite work, because both men and women have armpits. Men's may smell more, but that could be a cultural thing about washing. But we do also smell slightly different from women if we're men. And the chemicals have been looked at, but not really fully investigated. But I think the crucial thing is that it develops in adults, and our smell changes markedly at puberty. And it's all to do with these secondary sexual characteristics, to do with the glands that are growing, these specialized sweat glands, and also the hair for the bacteria to grow on, that really make the smell. But the thing we're missing is any real knowledge of how odour is used in human mating. We know a lot about moths, a lot about mice, but very little, even after Masters and Johnson, about humans. So which areas are possible smell sources? And in fact, the answer comes from Icelandic swimming pools. This is the sign in Reykjavik swimming pools. And they give you this sign in the changing rooms, which is giving you the places that you really must wash. And you'll see that these include the armpits, the head, which also has lots of scent glands, around the genitalia. I'm not so sure about the feet, but that is important for swimming. And in case you don't get it, in 5 languages they explain every guest is required to wash thoroughly without a swimsuit before entering the pools. So these are the really smelly areas that probably we should be looking at for human pheromones. Now, if you Google human pheromones, or indeed pheromones, you'll end up with something approaching 2 million hits, most of them trying to sell you something. Sadly, there is no human pheromone chemically identified yet. A lot of the commercial sites will try to sell you this substance, androstenone, and some scientific studies use this, but actually I don't think they're using the right thing. Because although this is found in human armpits, there is no more in the male than the female. And if this was a sexually selected signal in mate attraction, we would expect that. But the crucial thing is that nobody, for any human compound, has done the scientific bioassay-guided evidence that Buttendant established in 1959, where you can really be sure that the molecules you're studying really are the pheromone. So, what about the success of the smelliest? You can perhaps have too much of a good thing. Catullus, the Veronese poet, was giving some advice to his friend Rufus. Don't be surprised that no woman's willing, Rufus. They say a fierce goat lives in your armpits. But actually, let's be even-handed here, because Ovid a bit later advises women, don't keep a goat in the armpit. And it is true that some of the molecules that you find in unwashed human armpits are indeed those that I mentioned earlier, found in goats, along with 600 or 700 other molecules. And of course, that's what makes it so hard to identify what is the pheromone. So what I've tried to persuade you is that almost all animals, including humans, use pheromones for communication. Pheromones evolved by natural selection, aided by sexual selection. And humans surely do have pheromones, I'm confident of that. But sadly, the chemicals have yet to be discovered. There's more on these websites, and do read on. Thank you very much for listening.